Yeah, can you see the screen? Well, okay, so so this is the allowed range of values for J. So J is 0 or 1, and M is the sum of SEZ and SPZ. So given these two information, we see that when J is equal to 1, so J is equal to 1 means the corresponding M value can be 0 and plus minus 1, so 3 allowed values. And M is equal to 1 only when SEZ equal to half and SPZ equal to half, because that is what their maximum values are. So there is no other choice but to identify these two states. So J equal to 1, M equal to 1 is identified with SEZ half and SPZ half. Now from there we have to find the other M values, other states corresponding to other M values. How to do that? So from J equal to 1, M equal to 1, we can reach J equal to 1, M equal to 0 simply by acting with the lowering ladder operator. So, and we know the total uppering or lowering ladder operator is equal to the summation of the corresponding lowering and corresponding lowering ladder operators of the electron and positron. So this is the sum of two individual subsystems. Okay, so act with S minus on J1M1, and in the right hand side you act with the individual operators of the individual systems. So finally you collect all the results, and this is what you conclude. So J equal to 1, M equal to 0 is the linear combination of these two states. So electron up spin, positron down spin, plus electron down spin plus positron up spin. So the equal linear combination of these two states. And similarly the J equal to 1, M equal to minus 1 is achieved when both electron and positron are in down states. So there is no other choice. Now J equal to 0 and M equal to 0 is another choice. We remember that J can be 0 or 1. So J equal to 0 is another choice, and J equal to 0, so only M equal to 0 can correspond to J equal to 0. So, and now since M equal to 0, so the ACZ plus SPZ should be 0. So their summation has to be 0. So there is no other choice but we have to take a linear combination of these two states. So one is electron up, positron down, and another is electron down, positron up. So only in these two states the total m is 0. So that means J0 M0 state has to be the linear combination of these two states. So, and moreover, J equal to 0 M equal to 0 state has to be orthogonal with J equal to 1 M equal to 0 state. So that means, so it has to be orthogonal with this state. So we can readily find such a linear combination. So these two are mutually orthogonal, as you can easily see. So this much is fine. So we have found the 4 energy eigenstates. Now we can simply act with H and find the eigenstates. So J equal to 1. So H was this a square minus ac square minus sp square. So H acting on J equal to 1 comma m. So it will not depend on the value of m. It will only depend on the value of J. So a square. So total a square is J into J plus 1 h cut square, and for J equal to 1 that gives you 2 h cut square. So this is this 2, and then for spin half you have ac square equal to half into half plus 1, so that is 3 by 4, and similarly for positron. So combining those two you get a 3 by 2 here, and thus your final energy level for this J equal to 1 m state is half h cut square a. And similarly, the J equal to 0 m equal to 0 corresponds to minus 3 by 2 h cut square a energy eigenvalue. So this is this. So that means your half h cut square a energy level is 3-fold degenerate. And how to explicitly find these eigenstates? So this up state means this is the direct product between these two up states. So 1 0 direct product with 1 0, that gives you this this 4 cross 1 column vector. So this up state is this 1 0 0 column vector. Similarly, the down state will be 0 0 1 column vector, and this up down state is the direct product between up state and down state. So 1 0 direct product with 0 1, and this will give you 0 1 0 0, and so similarly down up state will be 0 0 1 0. That will be the direct product of 0 1, direct product 1 0. So that will give you 0 0 1 0. So finally, combining according to this, your J equal to 1 m equal to 0 will be this combination. So it's not visible, and J equal to 0 m equal to 0 will be this combination. So so This was the discussion on this question. So if you have any question, please ask. So I have no more questions to discuss today. So otherwise, I will just end this session. Okay, so I don't think you have any question. So I am ending this session. See you next week.
Thank you, sir.
Yeah, okay, welcome.